Well, greetings and welcome to this video tutorial on the use of SPSS to conduct a mixed designs ANOVA. And so within a mixed designs ANOVA, we're going to be able to look at test hypothesis related to within group effects as well as between group effects. And then also, since we have a combination of two independent variables, one with the between group, and in this case we have our between group variable has three groups here. We have approximately 4 people per group, and since our within subjects independent variable, this could be time or 4 different conditions by which the same individuals have been exposed to. Maybe these are different types of training or learning modules in which we're looking at levels of satisfaction with or perceived relevance to promote professional practices. We will be able to look at the interaction effects too, meaning that do these conditions influence group individual outcomes differently across depending on which group you are in. And so this will be the purpose of the mixed design then. So it builds on both components of like a one-way ANOVA as well as a within subjects ANOVA, looking at the between group differences as well as the within. And so in here, we have these 3 different conditions here. These might be, different practices to promote student outcomes or promote client outcomes as well, depression or anxiety, or within a clinical setting or medical setting, looking at issues around quality of life. And then we have measures across 4 occasions here. And so just like within any of the analysis of variance procedures, we're going to be looking at comparing means, or in this case, the general linear model. In this case, since we do have the within subjects component, we're going to be doing a repeated measure. So we're going to go analyze, general linear model, and repeated measures. Our first factor 1 is for the within subjects. And since we have 4 levels to it, B1 through B4, we can give it a measure name. We can just call this perhaps time if these are repeated measures over time. If these were specific conditions by which individuals were exposed to different types of professional development trainings, we might be able to call this like trainings or condition. If we click continue, then we see we have these 4 time factors here, and so we'd want to put these in the order by which they may have occurred. So make sure if you have really a time 1, maybe this is a pre-test, a baseline, you want to make sure you follow that time sequence so they're in the order by which the data was actually collected. Now what's unique here to the mixed designs is we're going to have this between subjects, and so this builds off. If we were just going to do it within, we would just look at score changes over time for the whole group irrespective of the group membership. But in this case, we're bringing in the group membership variable here, group, and that's going to be our between subjects factor. Within here, if we go to contrast, this is our way to test, at what point over the repeated testing are the scores different than previous scores. And so in this case, for the factor 1, maybe we want to do the repeated. And this is going to test whether or not the time 2 score is different than the 1, the time 3 score is different than the 2, and the 4 is different than 3. So it compares that score to the previous collected data point. And so if we click continue, make sure once you hit repeated, you hit that change button. Plots are highly recommended for any type of study in which we have multiple independent variables or even within subjects to kind of look at these score changes over time. Even though we can look at the average scores within a table, it's often desirable to have a visual representation of the data. And so we'd put the factor into the horizontal, and then we want separate lines for groups. Click add, so that way we get factor 1 times group. For post hoc, we're only going to have this for group. This would only be necessary if our group variable had 3 or more levels to it. We can ask for perhaps a Tukey. The estimated marginal mean, so in this case, we'd want to get means for all the respective groups. We can click continue. And then lastly, our options. This is going to give us options. Maybe we want descriptive statistics, although we're working under the assumption that you've already inspected the descriptive statistics just through like looking at frequency distributions, measures of central tendency, variability to kind of do some data screening. So there is a working assumption that we've already kind of screened the data to kind of identify any potential outliers or scores that just don't seem to represent the data that was collected on the population or the sample. We can ask for estimates of effect size. This is going to give us that partial eta squared. However, it's desirable to have omega squared because it is more conservative. We always want to err on the side of caution within our work. And the homogeneity test, because again, one of the key assumptions, at least for the within subjects, is that assumption of sphericity, and we always want to be able to check for our model assumptions. With that, then, we have our analyses kind of set up, and click OK. And so here we just get some basic information. Here's our dependent variable, B1, 2, 3, 4, had 4 levels. Our between subject had 3 levels, and it indicates the sample size within each when we see that 4. So we'd always want to check to make sure that the number of subjects including the analysis is equal to what we had in the data set. We don't want to come across any discrepancies here. And then we also have then our descriptive statistics for each of the respective groups within each time point here. So if we come down, we start getting information related to the analyses. The multivariate test is not going to be relevant at this point. But it would essentially tell us, there are group differences across repeated measures, but for a purpose of our analyses here, we're going to skip over that. The first table we come to that does give us relevant information is this Moschli's test of sphericity. This is the assumption of sphericity. This is a key assumption that we need to check on within the within subjects ANOVAs. And so what we want to look at is we have our test statistic is the Moschli's W statistic is 0.56 on 5 degrees of freedom with a p-value of 0.49 if we round up. So we can see here with this non-significant, we say we can accept that the sphericity assumption has been met. Other values as greenhouse geyser, the closer that is to 1, we are additional evidence that we have met this model assumption. Where this again comes into play is it tells us which line within the within subjects effects table we can look at. Since we've met this assumption, we can stick with the first row, sphericity assumed. So our F statistic is 127.77 on 3 degrees of freedom, and our p-value is less than 0.05. If, however, we didn't meet it, we could use the greenhouse geyser or the Hohenfeld statistic. Both of these are more conservative, and they help to reduce our likelihood of committing a type 1 error. And you can see that the F statistics are all the same. The only thing that does differ across these is the degrees of freedom, and you can see the greenhouse geyser has a lower degree of freedom, so it's going to be more conservative, but that's the only change that it makes there. So we can conclude here that we can accept the alternative hypothesis that scores are not the same over the 4 repeated testing occasions here. Within this table, we also get the interaction effect, meaning that we've met the sphericity assumption. Our F statistic is 7.07 if we round up on 6 degrees of freedom, and our p-value is less than 0.05. So there is differences across groups in terms of their scores over time. And so if we are going to expose individuals, be it students, clients, counselors, to different types of learning experiences, those learning experiences were different across repeated measures across those groups. That's what that's telling us. I'm going to jump down past this table. We're going to come back to it because we still need to test our between subjects, the main effect for groups. And here we get the Levene's test of equal variances. This is just like we saw within the two-factor one-way ANOVA. And we see our p-values here all greater than 0.05. So we can see we've met the assumption across each of the repeated measures of testings. In our test of between subjects effects, this is the table by which is very similar to what we saw one-way or two-way ANOVA. But here for the group, our F statistic was 6.85. Our degree of freedom for between was 2, our error was 9, and our p-value was less than 0.05. And so here we can see that irrespective of time, there are differences across the group overall group mean scores. But again, our interest is largely in that interaction effect. With the test of within subject contrast, this is where we're actually comparing scores to the previous one. And so this is for the within subjects comparing time 1 and 2. We see the scores different irrespective of groups. This one here is not considering group. 2 versus 3, they were different. In level 3 and 4, all the scores different from the previous ones over time. For the interaction effect here, factor times group, we see level 1, 2, slight differences beyond 0.05, but then there's no difference between levels 2 and 3. And I'm going to have a supplemental module that will go through more fully looking at score differences within each of the respective groups, and even with across the groups once we control for the time. And we'll look at this within the graph. Here we have our estimated marginal mean, so the overall group mean, irrespective of time or group, for everyone was 18.75. Each of the group means was 14.5, 20, 21. Really the most important thing is since we saw we have within subject score differences, we also had interaction effect, and we also found group between group score differences. And so here in this case then, the graph can help us visualize this. So for example, maybe group 1 was our control condition where maybe we just had people business as usual. Group 2, they were exposed to maybe some kind of online training with some kind of assessments built in to promote knowledge, cultural responsive practices. And then the green condition here, group 3, maybe they also had the online, they had some assessments, but maybe then they also had some individualized consultation sessions with a trainer to kind of help further build individual confidence and knowledge. And so what we can see here is that if we look at this control group, their scores slightly changed over time. What this would do, for example, is considering the threat to internal validity. And so one threat to internal validity is maturation. And so anytime we're doing something over time, the threat of maturation comes into play because we just naturally learn, develop, grow, acquire knowledge without any specific intervention, just through information we learn from our day-to-day exposure to individuals and television, reading, so on and so forth. But what we can see here then for groups 2 and 3, clearly over time their scores increase. And so this where we would see an interaction effect where time 1 was our baseline. Scores were pretty comparable, but then once over time we see for the groups 2 and 3, their knowledge or their confidence or patients' quality of life increasingly increased above and beyond just what we saw with the control group. And so one of the subsequent analysis, what we'd want to learn then is at each one of these time points, time 1, 2, 3, and 4, where do these score differences play themselves out? Are there score differences really here at time 1 across the groups? Here we would assume groups 2 and 3 are significantly higher than 4, but we would need to go and empirically test that. Likewise for groups 3, 2, 1, where do their scores start to statistically significantly increase? And that's something we would need to look at within breaking apart this data a little bit more. But just within the mixed designs here, what we are testing is the within subjects score changes over time, the between group in terms of are there a main effect for group irrespective of time, and then that interaction. This concludes this video module on mixed design.